In this session, I would like to discuss with you about why do building and civil engineers need BIM. As we have known that BIM represents technology advancement in management of product and process information in the AEC industry. However, people may argue that technology advancement alone does not provide the necessity for adoption of BIM by engineers and may provide some examples showing the traditional technology can still do well. Here, I'm not trying to argue that the traditional technology no longer works, but just want to show you the reasons why BIM is becoming a necessity for building and civil engineers in the AEC industry. People often refer to the 2003 report by NIST, National Institute of Standards and Technology, USA, to indicate the long-term issue of poor productivity in the construction industry. As you can see in the figure, construction labor productivity did not go up like the non-farm labor productivity, which was more than doubled from 1964 to early 2000 in almost 40 years. The construction labor productivity even went down gradually. The report pointed out 30% total waste and $15.8 billion per year due to absence of software integration and interoperability as the main cause for poor productivity. It was said that the U.S. government therefore started to take actions to help the construction industry improve its productivity with the establishment of the National 3D 4D BIM program by the U.S. General Service Administration. Besides the perspective on productivity improvement, let us think about the many challenges all building and civil engineers are facing today and beyond. After the following discussions, I think it should become clear to you why building and civil engineers need to develop better ability and deserve to be equipped with better technologies and tools, like those provided by BIM. Nowadays, engineers are dealing with more complicated projects of larger scale. As you can see, this is the Wei Wu Yin Center for the Arts at the Kaohsiung City of Taiwan. There are a lot of curved surfaces and the building is very complicated in terms of connected spaces of various functionalities. These are other views of this building project. It says that no typical plans can be found in the design. How many 2D drawings do we need to fully communicate the design if only 2D drawings are used? Obviously, engineers need better tools like those provided by the 3D BIM approach. Engineers are not just dealing with more complicated and larger projects. They are often asked to build things faster, deliver things with better quality, and provide safer working environment. For minimizing social and economical impacts due to construction, civil engineers often need to develop new construction approaches with very good planning and coordination of all construction tasks. For example, the Wells Street reconstruction project at Chicago only interrupted the traffic service for 9 days each in 2 consecutive months in 2013. The old double-decker steel bridge over the Chicago River serves 12,000 vehicles and 70,000 train commuters daily. The 9 days interruption included 2 weekends and 5 working days in between. It was said that the traditional replacement construction would take about a year, which would impact the life of Chicago people significantly. Nowadays, engineers are asked to address full life cycle management issues, especially for the operation and maintenance stage. Without good maintenance, failure of infrastructure may occur and impact our society significantly. Although people realize this, the task for maintenance is not easy but costly, especially when it is not carefully considered in the design stage and the information management for maintenance is not effective. Basically, we spend only about a short period of time for design and construction when compared to the time for operation and maintenance. For effective maintenance and operation, we need good product information management for our facilities. However, our current mainstream for product information management is still 2D CAD. We are building things in 3D, but in the past, we only had 2D tools and drawings to express our 3D design for communication and integration. So engineers need to convert 2D drawings back to 3D design for construction and maintenance. It's not difficult to know that information loss and inconsistency can easily occur during this 3D, 2D, 3D conversion process. In our current construction practice, the greatest effort is required to develop construction documents. Also, we know that the ability to control costs reduces from the beginning of design. On the other hand, the cost of design changes increases as the project moves on. If the project unfortunately goes into litigation, it will be very costly. So the idea is to move the efforts forward in the process to have a better control on cost of design changes and minimize the possibility for litigation. Furthermore, let us take a look at the business model for facility management. The gold curve represents the typical design-build approach with required maintenance. The red curve represents the typical approach failing to do routine maintenance and having to replace items early and more often. The blue curve represents an optimized approach with virtual modeling and analysis with reduced change orders and delivery time and lower operating and maintenance costs. The first savings identified are those coming from faster and lower cost delivery we just discussed earlier. These are the savings we are currently seeing from the implementation of virtual design and construction technology such as BIM. However, the significant savings are in the region of operation and maintenance phase. If we can do a better job with effective lifecycle product information management for facilities. Nowadays, engineers are also asked to have more sense of humanity and to provide total solution as a better service and with more consideration on user experiences. Engineers need to communicate engineering outcomes in a better way that non-engineers can easily understand. It is obvious that 3D presentation taking advantage of the virtual reality technology is much better than using 2D engineering CAD drawings. Both disaster prevention and sustainability are civil engineers' major responsibility. In the United Nations Sustainable Development Goals, many agendas are highly related to building and civil engineering. For example, clean water and sanitation, innovation and infrastructure, sustainable cities and communities, and so on. Moreover, the demand for intelligent facilities with healthy environments is getting stronger in recent years. Let us take a look at the Industry Revolution. The first industrial revolution introduced machines to replace human labor. The second one brought mass production. The third one introduced automation. The fourth industrial revolution may be highlighted by the following two things: intelligent cyber-physical system and mass customization. Because the construction industry is greatly influenced by the Industrial Revolution, it's not difficult to see more intelligence will be required in the coming years for engineers to design, build, and maintain facilities. Of course, there will be not yet known challenges in the future awaiting for engineers. With all the aforementioned challenges, I hope I have convinced you that engineers need to develop better ability and deserve to be equipped with better technologies and tools, like those provided by BIM. In my opinion, BIM represents a new ability of digital simulation of real world and information knowledge management in the cyberspace for better beforehand planning, design, coordination, and integration of architecture, engineering, and construction tasks. It's not just an individual ability, but a team one, which requires good team communication and coordination, and information sharing and integration.